Alright, this topic's called graphing a linear inequality when it's in slope-intercept form. Again, so many math words there, but honestly, it's just taking a couple tools that you learned before and putting them together. We're going to be graphing a line and then shading on one side of the line to show where all the solutions are. That's the basic gist of what we're doing in English, in plain English. So I might refer back to some of the other videos I've done, because if you're not sure what you're doing on those particular steps, the videos will explain them in a little more detail. Alright, so let me just put down an example of what the heck something like this could look like. In slope-intercept form, we're vaguely talking about something that's y equals mx plus b. Since we're talking about an inequality, we're not going to have an equal sign. We're going to have a less than, a greater than, less than or equal to, or greater than or equal to. So let's just start off with an example. Let's say we have y is greater than 3x minus 3. You can kind of tell, if you've been familiar with graphing, that we have a slope and we have a y-intercept that's being shown. So let's just write down our first step. What we're going to do is we're going to graph the line. So we're going to act like that greater than sign isn't there, and we're going to just graph y equals 3x minus 3. If you're not sure how to do that, I'm not going to go into it in big detail right now, but you can look back at some of my videos, and there's definitely one listed there. So how do we start graphing the line? We have to find -3 on the y-axis, because that's our y-intercept. And then for our slope is going to be 3 over 1. And so that means that we're going to go up 3 into the right 1 from our point that we just plopped on. So we're going to go up 3, 1, 2, 3, into the right 1. There's our second one. We're going to go up 3 and up 1. Very similar to graphing a linear inequality for a horizontal or vertical line, there's a step that you need to remember here. If we have less than or greater than for this, we need to use a dotted line when we draw this line. If we have greater than or equal to or less than or equal to, we're going to use a solid line when we draw this line. So after I plotted these points, I'm looking back. I have a greater than sign in my original inequality. So I need to connect these with a dotted line. So that's what I'm going to do. Dotted, 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 dotted. All right? That's important to show. Step number 2 is we need to pick a point and plug it in. Why do we need to do that? Well, there's a couple reasons why. Pick a point and plug it in. One good thing about inequalities is if you can find a point that is shaded, or that makes the inequality true, all of its friends on the same side of that dotted line will also make it true. So my favorite point to pick is the origin, otherwise known as 0, 0. So what do I mean by plugging it in? Well, at the beginning of this video I gave us an inequality. It's right at the top, and it's y is greater than 3x minus 3. I'm picking a point, the origin, and I'm going to plug in 0 for x and 0 for y. So I'm going to copy this over. Here's a y. We're going to put in 0. Greater than 3 times, oh, my x value is now x. And I want to see if this is true or false. So let's do PEMDAS on our right-hand side. This is going to stay 0. 3 times 0 is 0, and 0 minus 3 is -3. Is this true or is this false? Is 0 greater than -3? 0 is greater than -3, so I'm going to write true. Besides writing true, which writing the true part isn't important, let's go back to our graph up here. I tested 0, 0, which is right here. I got a true statement, so that means that all of these points on this side of the line will also be true if I plug them in. So that's what I need to do, is I'm plugging in a point to see if it's true or false, and that will tell me where to shade on my graph, which side of that dotted line. That's basically all you have to do for this, but let's try another example just so you can process it a little bit more. Alright, for our second example, let's use y is greater than -2/3 x plus 1. Again, first step we need to do is we need to graph the line, and it's y equals -2/3 x plus 1. We start by plotting our b value, finding that on our y-intercept, marking it down. We'll do a quick slope analysis, -2 over 3. That's going to tell us to go down 2 and to the right 3. Alright, so from the dot I just plotted, I'm going to go down 2 and over 1, 2, 3 and put a dot. Go down 2 over 1, 2, 3 and put a dot. Now, do I need a dotted line here or a solid line? Well, if I look back up, I have a greater than, so I need to use a dotted line. Okay, I'm turning the iPad a little bit. Try to get my, there we go, nice pretty dotted line. Step 2, I'm going to pick a point to plug in. Again, if my line isn't going through 0, 0, and this one isn't, I'm going to use 0, 0, because 0 times any number is 0, and it just makes it so much easier. So again, I'm all about good housekeeping, so I'm going to write down the original, and I want to erase that sucker. I want to write down the original inequality here so I don't goof it up. Alright, so when I plug in 0 for x and 0 for y, I get this. 0 greater than, oops, I forgot the negative sign. 0 times negative 2/3 plus 1. That's going to give me, that all goes to 0. Okay, is 0 greater than 1? No, 0 is not. So I'm going to write false. Big deal about writing false. That's not really that helpful. We have to go back to our graph. We tested this point here. This gave us a false. This is not true. It does not hold the inequality true. So I can't shade on that side of the dotted line. Instead, I shade up here because all these guys are going to make it true. And then you are all done with that problem. Let's try one more. Alright, I'm going to do 2 more problems. If you're feeling brave already and you want to try one on your own, you can copy this down, hit pause, and then just do it out on your own and then check back and hit play and see if we get the same answer. Either way, that's good. I will do one more after this too. So let's say we have y is less than or equal to negative 2x plus 5. Again, if you want to hit pause, now is a good time to do that. If not, stay tuned and work with me. So what we're going to do is we're going to graph the line first, negative 2x plus 5. And again, if you're not sure how to do that, go back and refresh yourself with a video from the past. So we're going to put our y-intercept here. We're going to go down 2 over 1, down 2 over 1. In case you're not sure where that slope came from, we can rewrite that like that, which tells us to go down 2 and to the right 1. Alright, and now I need a solid line. So I'm going to turn my iPad just a little bit. There we go, a nice solid line. Now I need to plug in a point. And again, I love to use 0, 0. And my solid line I just drew does not go through 0, 0, so I can use it legally. Copy this original down. Alright, 0 for y, 0 for x. Do PEMDAS on the right hand side. Negative 2 times 0 is 0. 0 plus 5. Is 0 less than or equal to 5? Yes, it is. So I tested this point. It gave me a true, so I'm going to shade on that side of the line. And that should do it. Alright, let's try one more example. Alright, let's see. Let's try another example. Let's do y is greater than or equal to negative 5x plus 1. First step, if you want to hit pause, go ahead and hit pause. First step, we're going to graph it as if it was a line. And we need to plot 1 on the y-axis. Our slope is to go down 5 and over 1. So 1, 2, 3, 4, 5 and over 1. It's a nice steep line. We have greater than or equal to, so we need to use a solid line. That's kind of a little bit easier. Cool. And our second step, we want to plug in, this does not go through 0, 0 either. It's really close, but it doesn't quite. So we're going to plug in 0 is greater than or equal to negative 5 times 0 plus 1. When I PEMDAS this side, negative 5 times 0 is 0. Is 0 greater than or equal to 1? No, this is false. So I tested this point, it's false, so I need to shade all the way on this side here. And that's it. That's all I got. If you have any questions, come find me and I'll see if I can help clarify. Thank you.